Hi guys, so I got this wonderful request for me to just go through some basic high school algebra, just so that you guys can be more familiar with the concepts that you may see when you go into college, or just for you who haven't been in high school in a long time and you're trying to relearn, or for the people who are actually in high school who may be struggling. This video is for you guys. Just as you guys know, I love you guys so much, but right now I am kind of going through a cold, but I really wanted to help you guys out because I know some of you guys are taking tests within the next 2 weeks. So if you guys can just be patient with me and my voice, you may hear me like have a little bit of a clear throat type of thing a few times. I really love you guys. I really want to help you. So just have a notebook handy, have your pencils ready to go, and let's go ahead and learn high school algebra the simple way. So these are the topics that we're going to go over. First, let's go ahead and go over fractions. Then we're going to go over decimals, variables, terms, solving equations, solving two-step equations, graphing, and then we're going to go over proportions. We're not going to make this video long. We're not going to go over every single thing, but I know at the end of this video, you guys are going to feel way more confident in learning high school algebra. So let's go ahead and get started. So we're going to first start with fractions. So we're going to learn how to add. We're going to add. We're going to learn to multiply fractions. And we're going to learn to simplify them. Okay, so with fractions, we say we have the fraction 2 over 10 plus 5 over 10. When you're adding fractions, as long as they have the same denominator, you're able to add them. The denominator is the bottom number. The top number is called the numerator. So in this case, the denominator for the first fraction is 10. The denominator for the second fraction is 10. Because they have the same denominators, you keep 10 as the denominator in the answer. And then you can go ahead and you can add the numerators. 2 plus 5 is 7. So let's go ahead and do another one. 3 7s plus 1 7. As long as they have the same denominator, the answer is also going to be the same denominator, and you can go ahead and add the numerators, 3 plus 1, which is 4. Okay, so on your piece of papers, go ahead and write 1/5 plus 2/5, and let me know what you get. Okay, so because they had the same denominators, you know that they can go ahead and be added together. And then 1 plus 2 is 3. Okay, so then what happens when you get a fraction that's like 1/2 plus 2/4? So now if you look at these, they have different denominators, so you can't go ahead and add them yet. What you have to do is you have to make the denominators the same. The way that you make denominators the same is I like to write it 1/2 and 2/4. The way that you make it the same is that you have to choose a denominator that you can easily change both of them to. So if you count by 2s, 2, 4, 6, 8, and you count by 4, 4, 8, 12, 16, look in both of those lists and see what is the number that is common that's the least. So it would be 4. That is going to be the new denominator. So because this already has 4 as a denominator, I'm going to keep the numerator the same, 2 over 4. But this one goes from 2 to 4. So how do you go from 2 to 4? You multiply by 2. 2 times 2 equals 4. Whatever you do to the denominator, you do to the numerator. 1 times 2 is 2. So our new fraction is 2 over 4. So now we have 2 over 4 plus 2 over 4. They have the same denominators, so the denominator is also going to be 4. And then you just add the numerators. 2 over 2 is 4. So our answer is 4 over 4. So we went over how we're adding fractions, and we went over a little bit of how we can add fractions that have different denominators. Again, what we did in order to add fractions with different denominators is we circled both of the denominators, and then we counted by each of them. Here we counted by 2, here we counted by 4. After we had a few numbers in each list, We look at the numbers to see which were common, and the 4s were common, and the 8s were also common. But the reason why we chose 4 as the denominator is because it was the least common multiple. So we changed both fractions to have a denominator of 4. Whatever you do to the bottom, you do to the top. And now you have 2 fractions with the same denominator, and you were able to go ahead and add them together. If you need more practice with fractions and adding fractions or multiplying with fractions, I'm going to leave the link to my AccuPlacer workbook. That gives you practice with basic fractions, adding them and multiplying them. But that's the basic. So now we've gone over adding fractions. So we've done adding fractions. Now I want to go over simplifying fractions. I know we're skipping multiplying, but I just want to talk about simplifying fractions. The reason why I want to go to simplifying fractions is because our answer is 4/4. Anytime you see a fraction, you should understand what a fraction actually means. Fractions are parts of a whole, but another way to say 4/4 is to say 4 divided by 4. You're taking the top number and you're dividing it by the bottom number. 4 divided by 4 is equal to 1. What about 10/5? That's the same as saying 10 divided by 5. So 10/5 is the same as saying 10 divided by 5. 10 divided by 5 is equal to 2. So there will be times where you get an answer and you can just do this method, which is you divide the top number by the bottom number. So this usually happens when the top number and the bottom number are the same. This also happens when the top number is larger than the bottom number. That's when you can go ahead and simplify by dividing. So on your piece of paper, write dividing to simplify. Okay? So don't get confused. Don't get overwhelmed. I know I'm giving you a lot of information, but it's very simple information. Again, when you have the number that's on the top and the bottom that's the same, you go ahead and divide to simplify. And when you have the top number that's larger than the bottom number, you divide to simplify. Those are the two situations when you divide to simplify, the top number by the bottom number. But sometimes you have something that looks like this. I'll do 6/12. Now, the top number is not the same as the bottom number, and the top number is not larger than the bottom number, but we still need to simplify. So how do we do that? We do it slightly different. So we have 6/12. What we do is we find a number that can go into 6 and a number that can go into 12. You may say, okay, I know that 6 can be divided by 6 and 12 can be divided by 6. 6 divided by 6 is 1. 12 divided by 6 is 2. 6/12 simplified or reduced is 1/2. Okay, what happens if when you looked at 6/12, you said, oh no, Miss Amber, I did not see that 6 and 6 can go into it. That wasn't my first instinct. My first instinct was they both can be divided by 2 because they're both even numbers. Well, go ahead and divide both by 2. 6 divided by 2 is 3. 12 divided by 2 is 6. Okay, so you started by dividing by 2, but the one thing you have to do is you have to keep checking if there's another number that can now go into 3 and 6. And the answer is yes. You can divide 3 by 3 and you can divide 6 by 3. So 3 divided by 3 is 1. 6 divided by 3 is 2. So now you get 1/2. So the difference between what we did in this situation is that we used the largest factor of 6 and 12. What we did here is that we used small factors of 6 and 12. You ended up with the same answer, but in this situation, you had to keep dividing. Both ways are right. If you're able to see what the largest common factor is between 6 and 12, go ahead and divide, and you easily, in one step, have your fraction simplified. If it's easier for you to do smaller factors, go ahead and do a smaller factor. But when you get an answer, like we got an answer 3/6, please just in your brain say, is there a way for me to simplify this even further? Is there a number that can go into the top number 3 and also the bottom number 6? If the answer is yes, divide again. So in your brain, if I use a larger number or the largest number to simplify, then you're finished. If I start with smaller factors, then just keep going a few times. The test always will be, in both situations, is if you can divide a number into the top and the bottom that's greater than 1. In this case, the only factor that goes into 1 and 2 is 1. There's no number greater than 1 that you can divide both of these numbers by. So in the simplest form, it's 1 over 2. Again, if you need some more practice simplifying fractions, just let me know. But because I want to cover many topics with you guys today, and I want this to be more of an overview, we're going to go ahead to multiplying fractions. Now, multiplying fractions is my favorite because it doesn't matter what the denominators are. So 1/3 times 1 over 4. So when you're multiplying, you don't have to care if they have the same denominators or not. All you do is multiply the numerators and then multiply the denominators. So 1 times 1 is 1, 3 times 4 is 12, and the answer is 1/12. Let's do that again. 3 over 4 times 1/6. Because the denominators do not have to be the same, you just multiply the numerators and then you multiply the denominators. 3 times 1 is 3, 4 times 6 is 24. The answer is 3 over 24. But we have to be careful. When we get an answer 3 over 24, we have to ask ourselves, is there a way to simplify this fraction? Meaning, is there a number that can go into 3 and 24 that's greater than 1? And yes, you can divide them both by the number 3. 3 divided by 3 is 1. 24 divided by 3 is 8. So simplified, the answer is 1 over 8. So do you see why I taught you guys how to add fractions, then simplify them, then multiply them? Again, when adding fractions, they have to have the same denominator. When simplifying fractions, you divide by factors. If you divide by the largest factor, then you can get your answer very quickly. If you divide by smaller factors, then you have to continue doing it until you're not able to divide any further. Okay, guys, well done with fractions. Let's go ahead and make a little check mark. And now let's go over decimals. When we go over decimals, we're going to be rounding. We're going to be talking about place values and changing them to fractions. So let's go ahead and do decimals. On your piece of paper, let's write decimals. We are going to be rounding. We are going to talk about place values and changing to fractions. And I know it also said reading, and that's going to be part of changing to fractions, but let's go ahead and talk about reading as well. Okay, so let's talk about decimals. So on your piece of paper, I want you to go ahead and write this decimal, 0.375. Let's talk about place values first. So place values just mean what is the value of each digit when you write it in this order. So next to the 3, I want you to write tenths. Put an arrow to the 7th, that's the hundredths. And the 5 is in the thousandths place. Okay, so if you need a place value chart, it starts with the decimal point here. Then it goes to tenths. Then it goes to hundredths. Then it goes to thousandths. Okay? So if I were to put 689.689 into a place value chart, the 6 is in the tenths place, the 8th is in the hundredths place, and the 9 is in the thousandths place. Use a place value chart if you need help. Again, if you need more practice with place value charts, I have a few of them in my AccuPlacer workbook. It just goes over basic arithmetic, so it applies even if you're not taking the AccuPlacer exam. It just goes over basic arithmetic. So it also goes over place values. So the reason why it's important to know place values is because sometimes when they're telling you to round, they'll tell you to round to the nearest place value. But also when you're converting a decimal into a fraction, you need to know, okay, the place values, because if you can read it, then you can change it into a fraction. So what do we want to do first? Do we want to learn how to round them, or do we want to learn how to read them and put them in fractions? Let's talk about rounding first. So if I had 0.689 and they told me round to the nearest tenth, I need to know place values. I need to know that the number 6 is in the tenths place. And so whatever place they're telling you to round, you underline that number. The 6 is in the tenths place, so I underline the 6. So you underline the number they want you to round to, and you draw an arrow to the number next to it, to the right. The reason why we're drawing an arrow to the right is because we have to look at the number to the right of this number, and we have to say, if that number is 5 or above, we're going to round that number 6 up to the next number. If it's 4 or below, we're going to keep that number 6 the same. So if we go over to the neighbor's house, I like to teach it this way. I know it sounds a little bit juvenile, but it's my favorite way, and I'm an adult. So if you go to the neighbor's house and the neighbor says, okay, I'm 5 or above, that means you can borrow something from the neighbor. Pretend like you're borrowing sugar. If you're able to borrow sugar from the neighbor, then you come home and you're bigger. If the neighbor is 4 or below, that means it doesn't have any sugar for you to borrow. And what happens? You just stay the same. So if you make the arrow to your neighbor 8, is the 8 big enough to borrow some sugar from? Is it 5 or above? Yes, it is. So you take some sugar from your neighbor and you come home, and what happens? You're bigger. So now instead of 6, you round up to 7. Now that you're done borrowing, you cross off all the numbers that are after the underlined number. So your answer should end in the tenths place because you're rounding to the tenths place. Again, you cross off after you borrow from your neighbors. Unfortunately, you're done with them. And so now you cross them off and your answer should end in the value place. So let's try this again. So 0.689. Round to the nearest hundredths place. Okay? So again, we underline the hundredths place, which is the 8. We know that because we either memorize them or we use the place value chart. The 8 is in the hundredth spot. We put an arrow to our neighbor because that's the one we're either going to be able to borrow sugar from or we're not. So we look to our neighbor 9. 9 is 5 or above. So what do we have to do? We round up. So instead of coming home and still being an 8, we come home and be a 9. So we cross off all our neighbors, but the numbers before us we keep. So 0.69. We keep this number because it's before the numbers that we were rounding to, but we cross off all the neighbors that we used and behind them. So 0.69 would be this number rounded to the nearest hundredths. The way we know we've done this correctly is because the last number should be in the hundredth spot because we were rounding to the nearest hundredths. And that 9 is in the hundredth spot. Okay, so now that we've practiced rounding, let's practice reading this. So 0.689. Remember, we had it in our place value box. So what I'm going to do is just copy this. Copy this, and I'm going to put it here if it helps. Okay. All right. So how do we read this? Very simply, the way we read this is we read this whole number like we would read any number, 689, and then we just add the place value word of that last digit. The 9 is in the thousands place. So the way we would read this is 689 thousandths. How would we read 0.68? Well, we would just read this number, 68, and then this last digit is in which place? It's in the hundredths place. So it would be 68 hundredths. Okay, how would we read this? 0.6. Well, the last digit is in the tenths place. So we would read the number 6 and then add tenths, 6 tenths. It's very simple. If you can read it, then you're able to put it into a fraction. Well, how do we do that, Miss Amber? Well, let's go ahead and talk about that. 0.689, 0.68, and 0.6. When we read 689, it's 609 thousandths. When we read this, it's 68 hundredths. And we read this, it's 6 tenths. So let me move this over to the side. And let's see how easy it is to put into a fraction. We take the word number 609 and we put it on top. And then we put the place value word thousandths on the bottom. We have a fraction. Okay, 68 hundredths. We put the number word on the top, 68. We will put the place value word on the bottom, 68 over 100. What about 6 tenths? We take the number word and we put 6 on top. The place value word we put on the bottom. If you can read a decimal, then you can put it in a fraction. If you know place values, then you can read a fraction. And if you could read a fraction, if you know place values, you can read a decimal. And if you read a decimal, you can put it into a fraction. Very simple. But then we also learned how to simplify fractions. So if I said, let's simplify 6 over 10, do you remember how we're going to do it? We choose a number that can go into 6 into 10. It's 2. 6 divided by 2 is 3. 10 divided by 2 is 5. 3 over 5. We know that we've simplified it all the way because we can't divide any other numbers into 3 and 5. Even though this was a small factor, it was the largest factor of 6 and 10, so we don't go any further. Okay, guys, I know you guys are hanging in there, and I know we discussed a lot of things, but I feel like you guys are also learning a lot too, so let's go ahead and cross off decimals. Now let's talk about variables. So I'm just going to add a page under here so I don't have to keep scrolling so much. So now we're going to talk about variables, adding and multiplying variables. Adding and multiplying. Okay, so variables are just letters that you see in math. So if you see X, A, Y in an equation, those are all variables. So again, variables are any letters that you see. But sometimes you'll see them with a number in front of them. Like 1, 3, or 4. The number in front of them is called the coefficients. You don't need to know that word, but just so you know, the coefficients are in front of them. Okay, if you ever see a letter that has no number or no coefficient in front of them, there's always an invisible 1. Again, if you see any variables, X, Y, Z, with no number in front of them, there's always an invisible 1 in front of them. So how can we go ahead and add? I'm going to add another sheet. How do we add variables? Well, say we have X plus X. Since there's an invisible 1 in front of both of these X's, 1X plus 1X is equal to 2X. How did I get that? It's the same as saying 1 apple plus 1 apple is 2 apples. The X's stay the same and you just add the coefficients. The reason why everything just stays the same is because we're just adding and because the X's are to the same. They're the same power, X to the 1. So because they're the same, you just add the coefficients 1 plus 1 and that equals 2X. So what about 3X plus 1X? Because they have the same variable X to the same degree to the first power, you can just add the coefficients. 3 plus 1 is 4. What happens if you had 4X plus X equals? Well, go ahead and add that invisible 1, and then you do 4 plus 1 is 5, and then x, and the x just keeps as x. Remember, x to the first power and x to the first power also gives you an answer with x to the first power because you're just adding them. Okay, so we talked about variables. We talked about adding them. Now let's talk about multiplying variables. So if you had x times x, because you're going to see this a lot. So now this is not adding anymore. It's multiplying. So a different rule applies. So when you're multiplying and they have the same variable, you have to add the exponents. Write this as a note. When you're multiplying and they have the same variable, you need to add the exponents. So what are the exponents? When nothing is here, it's always to the first power. So these are the same to the same power. So our answer is also going to be the same to the same power. And now you just add the exponents. 1 plus 1, x to the second power. Okay, x to the third power times x to the fourth power. Because you're multiplying and they have the same base, you just add 3 plus 4, and it'll be x to the seventh power. What about y squared times y to the fifth? Because they have the same base, you just add the exponents. 2 plus 5, y to the seventh power. Okay, and the last thing that I want to talk to you about is when you see 3x together, I want you to understand what that actually means. So when you see 3x like this, when they're written so close together, they're being multiplied. This information is so important when we go to solving equations. It's so important because when you know that they're being multiplied against each other and you have to get rid of the 3, then you have to do the opposite of multiplication, which is division. So you're gonna have to know what's happening now in order to get rid of it so that you can get rid of it by doing the opposite. So anytime you see 3x, that's the same as saying 3 times x. And if you see 4y, that's the same as saying 4 times y. And if you see 8z, that's the same as saying 8 times z. The reason why we need to know it just one more time, because if you have 4y is equal to 8, and they say get the y by itself, you're going to say what's causing the y not to be by itself, the 4. You're going to ask yourself, what's happening to the y? What's happening with the 4 and the y right now? It's being multiplied. To get rid of the 4, you got to do the opposite of multiplication, which is division. So you divide both sides by 4. The 4's cancel out, and you get y is equal to 8 over 4. We learned that 8 over 4 is the same as saying 8 divided by 4. So y is going to be equal to 2. Now, we're going to talk more about solving equations in a few minutes. But I just wanted to show you how important it is to know that when you have a number, the coefficient written right next to a variable, that is being multiplied. Even if you don't see a multiplication symbol, anytime they're being squished together, they're actually being multiplied. And the reason you need to know that is when you're solving equations, they say in order to get that 4 away from that x, you got to do the opposite of what's happening. Well, what's happening right now? They're being multiplied. So what's the opposite of what's happening? You divide. All right, let's carry on. So we went ahead and did our variables. You guys now know how to do fractions, decimals, and variables. So let's talk about terms, and let's talk about combining like terms. So we were talking about variables. Variables are just x, y, and z. By themselves, they're variables. They're always with an invisible 1, yes, but they're usually by themselves, x, y, and z. Those are the variables. The variables are just the letters. But when you have like 3x, 4y, and 10z, this becomes a term. The reason why it's a term now is because there's a coefficient and there's a variable. The z is just a variable. The 10 is the coefficient. A coefficient plus a variable equals a term. You don't need to know that, but it's just so that you can have some information and some background knowledge. Because the thing is that math is a language, you guys. You're going to read a question on your test. You're going to go into class and you're going to read something. And if you can understand that language, then it's going to be super easy for you. Because when they say combine like terms, and it's 4x plus 10x, if you know that the term is just 4x and 10x, then you know that when you add terms, 4x plus 10x is equal to 14x. You know that you don't have to do anything you're like, okay, I know what the word term means. Term just means these things together. Like terms, we're going to talk about that in a second. But when you add terms, it just means add them together. And that's super simple. 4x plus 10x is 14x. So again, a term is just the coefficient, the number, and the variable is the letter. So what about like terms? So if I wrote 12x, 4x, 3z, 4z, and 10x, which ones are like terms? Well, literally, you just have to look at the numbers or look at the terms and say which ones have the same variable to the same degree. So this is x to the first power, x to the first power, z to the first power, z to the first power, x to the first power. So 12x to the first power and 4x to the fourth power, those are like terms because they have the same variable to the same power of 1. But also 10x to the 1 is also a like term. Same variable x to the power of 1. So if they told me to combine like terms, that just means add 12x plus 4x plus 10x. So it would be 10 plus 12, which is 22. 22 plus 4 is 26x. I just combined all the like terms, meaning I combined all the x's to the power of 1, all the terms that had that, I was able to add them together. Now, can you spot two other like terms? Well, 3z to the first and 4z to the first. The reason why they're like terms is because they both have the same variable to the same degree. Even though those degrees were invisible, they have the same variable to the same degree. So we would do 3z plus 4z, which is equal to 7z. Ooh, 7z. All right, so now our answer would be this first term plus the second term, 26x plus 7z. We don't go any further. We cannot combine these terms. Why? Because they're not alike. This one has an x, this one has a z. Because they're not like terms, you just have to leave it as an expression. An expression is when you have two or more terms that you can't combine. So this is a term and this is a term. You can't go any further, but you have to indicate that they're still being added together. So you would just leave them together as a form of an expression. So we are going to go into more detail. I promise to make more videos about this. I'm not trying to give you every single thing that you're ever going to learn about math, but this is supposed to be an overview so that we can go to the next level, which is, I believe, it's solving equations. So the next one, we just learned about terms. Now we're going to talk about solving equations, and then we're going to talk about solving two-step equations. So let's go ahead and go to solving equations. And again, thank you guys so much for your patience with me. I'm not feeling well. I'm getting energized because I love teaching, but I don't feel well, you guys. And I'm doing this because I truly love you. And I know that you guys are about to take a test in a couple days. But please be patient with me in the comment section. Please show your love because it hurts when I'm not able to give 100%. But I'm trying my very best to give you guys as much as possible. Literally, I know once I turn this video off, I'm probably going to go to sleep for the next 3 hours. So if you're enjoying this video so far, please don't forget to give me a thumbs up. Don't forget to give me a follow if you want to stay tuned for more math videos. But also just please only love in the comments because I'll be so devastated that if you guys don't like this video after I've done it for you guys, just love me. Just love me. Anyway, I'm just kidding, you guys. So let's talk about solving equations. Okay, so we're talking about solving equations, and then we're going to talk about solving two-step equations next. So an equation can be x plus 5 equals 7. The x may seem a little scary, but they just want to know what is the value of x. So in order to find the value of x, you need to get the x by itself. With every equation, the goal, write this down, the goal is always to get the variable by itself. Okay, that is always your goal. If you always think of this as a game, as a goal, as something that you're trying to get, this is the goal. The goal is to get the x or the variable by itself and everything to the other side. Once this is completely alone, then you've won the game. But you have to ask yourself, what is causing the x to not be by itself? Well, in this case, it's the plus 5. So in order to solve equations, you have to figure out first, what is causing the x to not be by itself? The second question you have to ask yourself is, what's happening to that value right now so that we could do the opposite to get rid of it? So right now, that 5 is being added. So we need to get rid of that 5. So we need to subtract it from both sides. So it would be x, the 5's cancel out, is equal to 7 minus 5. 7 minus 5 is 2, so x is equal to 2. Does that work out? Let's check. X plus 5 is supposed to be equal to 7. So instead of writing x, let's find our answer, 2 plus 5. Is that equal to 7? Well, 7 is equal to 7. Yes, that works out. Let's try another equation. Let's try x plus 10 is equal to 20. The goal, get this x by itself. What's causing the x to not be by itself? This 10. What's happening with the 10 right now is being added. What's the opposite of adding 10? Subtracting 10. So if we want to get rid of the 10, we subtract 10 from both sides. 10s cancel each other out. The x is left. 20 minus 10 is 10. Our answer is 10. Does that work out? X plus 10 is equal to 20. 10 plus 10 is equal to 20. Is that true? Yep, it is true. So we got the right answer. All right, so now let's talk about solving two-step equations. Two-step equations are very simple. Sorry, a call is coming through. Two-step equations are exactly how they sound. They have 2 steps in order to solve. So now we're going to move to solving two-step equations. Okay, so two-step equations will look like this. 2x plus 10 is equal to 20. So, instead of just doing one step to solve the equation like we were doing before, now we're going to do 2 steps. So the way that we do this two-step equations is we have to figure out what is the goal. Again, the goal is always the same. Get the variable, the x, by itself. What's causing the x to not be by itself? Well, the 10 is causing the x to not be by itself, and the 2 is causing the x to not be by itself. So the first thing that you want to get rid of is the number that's on the same side but is not completely attached to the x, and that is the 10. Again, the first thing you want to get rid of is the number that's on the same side as the x but is not attached to the x. So that number would be 10. How do we get rid of the 10? Well, we do the opposite of what's happening. What's happening now, it's being added. So to get rid of it, you subtract. So we're going to subtract 10 from both sides. So we are left with 2x is equal to 10. Okay? So now what we have to do is the second step. That was the first step. And now we're going to do the second step. Okay, so the second step is we have to get rid of the 2 because the x is not completely by itself. We talked about this term, when they're side by side, they're being multiplied. So we have to do the opposite of what's happening. The opposite of multiplication is division. So instead of multiplying by 2, we're going to divide both sides by 2. The 2's cancel each other out, and you're left with x. And 10 over 2 is the same as saying 10 divided by 2, which is equal to 5. So x is equal to 5. So, as a review, two-step equations means you have to do 2 steps. First, you get rid of the number that is on the same side as the variable, but it's not attached to it. So we got rid of the 10 by doing the opposite. Then we get rid of the number that's attached to the variable, which was the 2. And the way that we get rid of numbers is by doing the opposite of what's happening. So in this case, the 10 was being added. So to get rid of the 10, we subtract from both sides. And to get rid of the 2, we do the opposite of what's happening. So the 2 is being multiplied by the x. So we divide both sides by the 2, which is the opposite. And we end up with x is equal to 5. Well, does that work out? 2x plus 10 is supposed to be equal to 20. So instead of writing x, we're going to write 2 times 5 plus 10 should be equal to 20. 2 times 5 is 10, so 10 plus 10 should be equal to 20. 10 plus 10 is equal to 20, so it works out. Let's go ahead and practice this again. So what about 2x plus 5 is equal to 17? Okay, what is the goal? The goal is to get the x by itself. What's causing the x to not be by itself? The 5 and the 2. Which number will we get rid of first? If you guess the 5, you're right, because the 5 is not attached to the variable. So we get rid of the 5. What's happening to the 5 right now? It's being added. How do we get rid of the 5? We do the opposite, so we subtract by 5. Okay, so now we have 2x is equal to, the 5's cancel out, 17 minus 5. 17 minus 5 is 12. So 2x is equal to 12. Now that we got rid of the number that is not attached to the x, let's go ahead and get rid of the number that is attached to the x, the 2. What's happening to the 2 right now? It's being multiplied. So how do we get rid of a number that's being multiplied? We do the opposite. So we divide. We divide both sides by 2. The 2's cancel each other out, and we're left with x is equal to 12 over 2. We know that 12 over 2 is the same as saying 12 divided by 2. And so 12 divided by 2 is 6. So x is equal to 6. All right. I'm going to give you guys one more problem to do. So we have 2x plus 30 equals 50. I'm going to give you just a few minutes, and I'm going to hum. Doom, 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 doom. Doom, 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 doom. Doom, 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 doom. Doom, 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 doom. Oh my gosh, is that tip me over and pour me out? Is that this? I thought I was doing the Jeopardy. I thought that was the Jeopardy song. Oh my gosh, I think it's the same as tip me over and pour me out. Oh my gosh, please tell me that's not the same melody. Oh my gosh, I'm looking this up as soon as I'm done with this video. All right, sorry guys. I never realized that. Epiphanies when you're sick, I'm telling you guys. All right, so let's go ahead and let's try to solve this together. So again, the goal is to get the x by itself. Okay, we're trying to get the x by itself. What's causing the x to not be by itself? The 30 and the 2. What do we get rid of first? We get rid of the 30 because it's on the same side as the x, but it's not attached to it. We get rid of whatever is not attached to it first. So we get rid of the 30 by doing the opposite of what's happening. What's happening now? It's being added. How do we get rid of it? By subtracting both sides by 30. So we're left with 2x is equal to 50 minus 30, which is equal to 20. Okay, now we have to get rid of the 2. What's happening to the 2 right now? The 2 is being multiplied by the x. How do I get rid of the 2? We divide both sides by 2. The 2's cancel each other out. X is equal to 20 over 2, which is the same as saying 20 divided by 2, which is equal to 10. X is equal to 10. Well, does that work out? Let's go ahead and see. So let's go ahead and rewrite the equation. 2x plus 30 equals 50. Let's put 2 times 10 plus 30 equals 50. 2 times 10 is 20. 20 plus 30 should equal 50. Does that equal 50? Yeah, 20 plus 30 is 50. 50 equals 50. The answer is correct. All right, so I'm going to give you guys more practice to practice two-step equations. Again, I have practice for two-step equations in my AccuPlacer workbook that I created. Although it is designed for the AccuPlacer exam, if you're going to try to go into college, it is also created for people who just need practice with basic arithmetic or basic equations. That's what it was created for. So if you guys need more help, you can look in the description box and you can purchase my workbook for $12. Just so you guys know, any purchases of my workbook It just allows me to continue putting time and effort and energy into making more videos. It also just makes me feel really good to know that I'm making something that's valuable for you guys, but also worth something. So if you guys want to purchase my workbook, even if you don't need the practice, but you just want to support Miss Amber, that'd be really great. You can always make a donation. Also, I have the link underneath to my GoFundMe if you'd like to make a donation for me as well. Let's go ahead and go over graphing. And so what we're going to do is we're going to just talk about equations for graphing. And we're going to spend more time with graphing, but just so you guys know, I also have a video about graphing as well. So I'm going to just go over the basics for graphing because graphing is a big deal in algebra. A lot of people don't like graphing, which is totally okay. But I'm just going to break this down for you guys in a way that makes you feel a little bit better about graphing. How about that? So the most common way to see an equation for a graph written is y is equal to mx plus b. This is called the slope-intercept form. So on your piece of paper, write slope-intercept form. It's so simple because it gives you the slope and the y-intercept. The slope is the m value. The y, so I'm going to write that. The slope is the m value. The y-intercept is the b value. Okay, so if you see y is equal to 4x plus 10, the slope is 4. The slope is equal to 4. And the y-intercept is equal to 10. What I need for you guys to know is that when the slope is positive, it means that this line is going up. When the slope is a negative number, it means the line is going down. So because this is a positive 4 slope, the line should be going up. If it was a negative 4 slope, the line would be going down. This is something really good to understand about a slope, because if you have to graph an equation of a line and you know the slope is positive, then after you're done graphing, if you look at your graph and it's going down, you know you've done it wrong. But if you look at your graph and it's going upwards, that is an indication that you potentially did the problem correct. So it's very important that you are able to know whether the slope is positive or negative, because you'll be able to know right away if the line is going up or if the line is going down. So I'm going to erase this because it can be a lot. Y is equal to 4x plus 10. So let's just talk about the 3 things we just learned by looking at an equation. Number 1, because the slope is positive, we know that the line is going to look like this. It's going to be going up. We know the slope is going to be equal to 4, and we know the y-intercept is going to be equal to 10. Now, let's talk about the slope a little bit more, and let's talk about the y-intercept a little bit more. And I know this may seem like it's going a little bit slow and dragging on a bit. I know that graphing is not very fun. I know a lot of people probably are going to tune out at this point. But graphing is going to be such like an integral part of your education in high school math and college math. And graphing is going to be the hardest bit of it. It is. So if you tune out, that's okay. If you plan to come back, but if you could just sit through a few more minutes of this, just sit through it and maybe you'll understand it a little bit more and maybe you'll hate graphing a little bit less. Okay, so by looking at this equation, I know that my line is going upwards. I know I have a slope of 4, and I know I have a y-intercept of 10. What does this all mean for me? Okay, so what does this all mean for me? The first thing I like to do with the slope is, if it's not in a fraction form already, I like to make it a fraction. You can make any number a fraction by putting it over a number. The reason why I like to make the slope into a fraction is because it's usually written rise over run. Meaning, it's either gonna, if it's a positive number, it's gonna go up 4, and then it's gonna go over 1. So 4 over 1 of a slope means you're gonna go up 4, you're gonna go over to the right 1. If you had negative 4 as a slope, put it over as a fraction, 4 over 1, that means you're gonna go down 4, and you're gonna go over to the right 1. So the reason why I like to write the slope as a fraction is because it can easily tell me, am I going up or am I going down on the top? And you always go to the right on the bottom. So that's the reason why I like to write the slope as a fraction. So in this case, we're going to go up. It's going to be a positive line. The slope is going to be 4 over 1, meaning I'm going to go up 4 and I'm going to go over 1. And I need to try to get this done before my iPad dies. I'm so sorry, guys. The y-intercept is always a point 0, comma, the y-intercept. So when you see the line 10, when you see the number 10 in the equation, 0, comma 10 is the y-intercept. So how would we graph y is equal to 4x plus 10? Let's go ahead and show this to you very quickly, and then we can end our lesson here today. And now you have a full overview of algebra. So we know that our line is a positive line. It should go in this direction. We know that our line is positive 4 over 1, meaning we're going to go up 4 and we're going to go to the right 1 as our slope. And we know our y-intercept is 10, meaning 0, comma 10. So I don't know if I made this line long enough. So 0, comma 10. Let's just pretend that it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 0, 10. First, you graph the y-intercept, which is 0, 10. First, you graph the y-intercept, and then you follow the slope, which is up 4 over 1. So this is not big enough. I am so sorry, you guys. This is not big enough. I didn't make a graph that was big enough for you guys. Let me just start one more time. And I'm so sorry. It's because I only have a 5% left on my on my iPad. So I just don't want this to cut off without you guys seeing the end of this video. And I've worked so hard for you guys. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Still not big enough. Let me make the line down here. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so the y-intercept is 0, 10. You graph the y-intercept first. Then you follow the slope, which is 4 over 1. So we go up 4 over 1. So up 4, 1, 2, 3, 4 over 1. And we do it again. Up 4, 1, 2, 3, 4 over 1. And we connect our lines. So did our line go up? Yes. Did it have a y-intercept of 0, 10? Yes. And did it follow the slope 4 over 1? Yes. We were just able to graph our line. Let's try another line. Y is equal to 2x plus 2. Okay, what do we know about this line? We know that this line is positive because the slope is positive, so our line should go up. We know that our slope is 2. We're going to put it as a fraction, 2 over 1. We're going to go up 2. We're going to go over 1. And we also know our y-intercept is also 2. So it's going to be 0, comma 2. So let's go ahead and graph it. First, we graph the y-intercept. Then we use the slope. So the y-intercept is 0, 2, 0, 2, 1, 2. So 0, comma 2. This is the y-intercept. And then we use the slope, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, and we connect our line. So then we can check. Did our line go up? Yes. Did we have a slope 2 over 1? Yes. And does it intercept the y-axis at 0, comma 2? Yes. So we were able to graph this correctly. If you need more practice graphing, I do have a video that I can link below with more graphing details. But I can also do more videos graphing and helping you guys, breaking down more fully when I feel better. So please let me know what you guys need. You guys have been doing so great so far. Please don't give up. Please keep watching. If you haven't subscribed already, go ahead and subscribe to my channel. Give me a thumbs up if you like my videos. And please give me a heart or something to let me know that you guys don't absolutely hate this video, even though I was sick when I was recording it. I really love you guys so much. And stay tuned for my next algebra video or my next AccuPlacer exam video, or just whatever video that it is that you guys need, or whatever help you guys need, or whatever requests I get. So I'll see you guys very soon, and I hope to see you guys also in the new year, possibly. All right, bye guys.